This is the office hours video for section 4, geometry. Now, one thing that some people get confused about is the difference between surface area and cross-sectional area. So as an example of that, I thought I would look at a cylinder. So here's a cylinder. You might think of it as a can, surface of a can. And let's compare the surface area with the cross-sectional area. So first of all, if I look at the surface area of this object, it actually has 3 surfaces. So what I'm going to do is add the areas of all 3 surfaces together. There are 2 ends, and then there's the curved part. So the area of each end is going to be pi r squared, which is the area of a circle. And then I need to add to that the area of the curved part. Now, the way you can think of that is to think of the circumference of a circle and then stretching that circumference of a circle down the length of the cylinder. So the circumference of a circle is 2 pi r, and then you'd multiply that by the length of the cylinder. Now what I want to do is simplify this as much as possible. I'll give the surface area the symbol A. So if I add the 2 areas of the ends together, that's 2 pi r squared. And then to make this easiest to use, I'm going to factor all the common terms out. So here's the final expression. 2 times pi times the radius, and then what's left is the radius plus the length. So that would be the area of the surface of the cylinder, and that area is the boundary between the object, the cylinder, and its environment. Now if I take that cylinder and slice through it, then I would be measuring the cross-sectional area. So imagine that this is, I don't know, a loaf of bologna, and I take a knife and I cut through it. So let's say I cut through it this way. I chop right down through the middle. And when I do that, what I get are 2 smaller cylinders. And so the cross-sectional area would be the new areas that's exposed. Now really, in this case, there are 2 of those. I'm not going to double count them, I'm just going to count them once. So the cross-sectional area in this case, if I slice it perpendicular to the length, then that cross-sectional area you can see is just the area of a circle. And again, I'm not going to double count. I'm not going to count both of those circles, just one of them. So the cross-sectional area would be pi r squared. And you can see that's different than the surface area. Let me use a symbol for that. Unfortunately, a lot of times we use the same symbol, A, for area. So you have to know from the context what the symbol is standing for, surface area or a cross-sectional area. Now what would happen if we took the same slab of bologna and instead of cutting it perpendicular to its length, we cut it across the middle like this. And so if you cut through it like that, let's say it's exactly through the middle, what you would get, the surface that would be exposed, if I look at it from the top, would be a rectangle like this. Whoops, let me try that again. That's better. So the cross-sectional area depends on how you slice it, which way you cut the object. So in this case, we get a rectangle, and 2 sides of this rectangle are the length of the cylinder, and then on the sides, that's the diameter of the circle, which is the same as twice the radius. I'll just write D for diameter. So in this case, if I cut it in a different direction, the cross-sectional area comes out to be just D multiplied by L. And if I wanted to express that in terms of the radius, the diameter is twice the radius. So the cross-sectional area would be 2 times the radius times the length. So it's important to recognize the difference between surface area and cross-sectional area. This will become very important later on when we start talking about how energy moves from one place to another because of a temperature difference. And that kind of energy is called heat. And the amount of heat that flows in various cases will depend on one of these kinds of areas. So it's a good idea to distinguish them as soon as possible. And I recommend that you go through the same procedure for other shapes, for example, spheres and cubes, simple shapes like that, because that'll be useful later on. So go ahead and try that out, and we'll see you later on.